Thank you. Hi, everyone. Good morning if you are from the east of the Atlantic, and good afternoon if you are from the west of the Atlantic. So I will show you some information about how to use naming if you are a developer, if you want to use the API. And so these are some of the tasks that we will talk about. How to generate a IUPAC name if you have a structure, or how to generate a command name from a structure. Conversely, how to convert names to structures, how to get a list of structures from the chemical names or the smiles or other things, embedded structures in Office documents, PDFs, text documents. I will also mention how to use your own web service to complement name to structure, which is a new feature that's available since 5.12. I will also mention how you can index a set of documents in the database, and a couple of other things that we will come upon during this trip. So let's jump in. So I hope that in general that the basic API is relatively simple, because what we're dealing with now is structures and names, which are well-defined objects in Java. Name is just a string. A molecule is an object created by ChemAxon, but basically you want to convert one to the other. So here we want to convert a structure to a name. So here you can see some code example. So in line 1, let's assume that we have a molecule. Here's an example how we might get a molecule using the mole importer API. This is a smile string, and so you import this molecule and get a molecule object. But you might have a molecule from any other way. And so here we are using the structure to name API. So we want to define a variable name, which is a string, and we will hold the name of the structure that we had here. And so the only thing you have to do is call the mole exporter class and say that you want to export this molecule to a certain format. And in this case, we said that the molecule M, you export it to the format name. And that's it. By doing that, you will get the name of the structure. Of course, if you use this API, you have to import the right package. All this is in the developer and the API documentation, and of course, for instance, you might get an exception if there are few structures which we couldn't convert to names. So you have to deal with that case as well. But that's really it for using the structure to name, except that you might have you might want to use options. So for instance, here we say that instead of using the name format, we'll use this syntax, which use a format on the left and then a column and then an option. So here the T is for traditional. So it will do two things. One of them is that it will try to see if it knows the command name for the structure, and if yes, it will return the command name. So for instance, here, I don't know how much you might be able to read this mice, but so this is acetylsalicylic acid, which is the name you will have here, and in this case you will have aspirin as a traditional name. In case there is no command name, the T option might still give a slightly shorter name because it makes some slight variations compared to the IUPAC rules. So this version name uses as much as possible strictly the IUPAC rules, and this one might simplify a little bit the name when it's not ambiguous. So that's the API. We can have a look yes, in some more options. So T is the option we used to get a traditional name. You can see that historically this was the kind of first option, and at that time we thought that we'd use short options, but actually realized it's not very user-friendly. So the later options use longer names, so they are easier to remember. But this is for traditional. So I already mentioned what it's doing. Common is a bit similar to traditional, but it's actually only generating a common name. So if there is no common name, T will return IUPAC name, but common will just fail. So depending on what you want, either of them could be good. One of the trick in if you use common, it means which common name, and the same structure could have many common names. So we have actually this option common, all, which will give just all of them, all those that we know. Common uses some heuristics and some algorithm to determine which one is the most popular, and it's not guaranteed that it will. Of course, it's kind of subjective, but it's a good guess usually. Then there is the option source, which is a bit special in that it actually doesn't do any generation. It's just that if you know in the API, and also, for instance, if you know the mol or the SD format, a molecule can have a name as just a text field. So if you imported a molecule from, for instance, the SD file, and it had a name which was associated with it, it could be a corporate ID, or it could be any name. Source will just give you that name without, so it will be immediate. It will not take any time. Of course, there are other ways to get this name, but this is useful as just for uniformity with other options, that you can also get that name if you want. Cast number is actually a new feature which will be in 6.0, so it's a preview here, that it will actually use a web service to try to find the cast registry number of the structure that you gave. Finally, timeout is an option that allows you to put a limit to how long it will take to generate the name. Usually it's really very short, but for very large structures it could even possibly take a long time, or even not finish if there is a bug. So this can be a safety, but the default is to use 20 seconds, which is much longer than usual, so it's just in case. But you might want to try harder for some long structures if you want, or you can even set 0 if you really want. But you can also set a shorter time if you don't want to spend time, because it's not that important, and usually it will be much less than 1 second. Here are some. So I sent a survey to the people who registered to this webinar, and I'm thankful to all the people who responded. It was useful to know what are your questions, and also what I got is that most people haven't used the API yet, so that's why I make mostly some simple introduction, but we will have some more tricks. So one question was how to get IUPAC names and or structures converted to trivial names. So the trivial name or common name, there are many nomenclatures for that. So we saw the option with either common or traditional. And so here, of course, if you have a structure, then this is what we are talking about, structure to name. If you have IUPAC name that you want to convert to trivial name, then you will actually need to combine what we will show next, which is convert the IUPAC name to a structure, and then you can convert again further that structure to a trivial name. And then by combining the two in just a few lines, then you convert IUPAC to trivial name. And the second question is, do we need to organize the query structure in a certain way? Chirality searching specifically for substructure structure. So here I'm not sure, because there might be slight misunderstanding about the query structure. So here we are not directly doing the query, because actually, for instance, for generating IUPAC name, it's an algorithm that will try to understand the structure. At the same time, it's true that for common names especially, it's actually some kind of search to find in the dictionary of common names which one it is. But so what I can say in general is that so anything that's not chemically importance, it should not matter in which representation your input structure is. So for instance, if it's aromatized or not, if the nitro groups are in one form or the other, these kind of things should not affect the result, because internally we will either understand both in the same way or canonicalize it. So it should work without any specific preparation. Well, chirality is something that will affect the name, so that's relevant, and you will get different name. And so this subset, I'm not sure. I think it doesn't really match I mean, you can, if you have a structure, you could build the core API of ChemAxon can allow you to build a subset of that structure, and then you can have the name of that. So this is the questions I got, and you have the chance now to, or later, to type your questions, and I will answer them at the end. But so now let's move on to name to structure. So just high-level presentation before going to the code is that name to structure, it works using two things. One of them is a dictionary of common and drug names, which is compiled using 9 different sources, and we use a specific method to combine them into one our own dictionary, which we try to make as accurate and also covering the most common cases. And so the resulting dictionary covers 150,000 names, which represent 40,000 unique structures. So there are obviously some synonyms in there. And we do, in addition to that, we support custom dictionary. There's a plugin system. We will see there's also the web service now. So there are different ways to extend that. And so that's one part, which is dealing with common and drug names. And in parallel to that, we also support systematic names. And so for that, we have our own algorithm, which understands the systematic name or the IUPAC names. And so the kind of names that this will handle is this kind of name, which has a logic. It's made of several parts. And this can be understood even if we never saw this name before. Since we are among developers, I will just show a little bit internally what's happening if it's not essential to use it, but just very quickly, what happens when you pass this name to structure. It will cut the inputs into small parts called tokens. So for instance, 2R is the specification of the stereochemistry, and then the 2 and the mat. You can see that the dashes are used for separation, but they're not relevant. So we are going to representation internally. So with this list of small parts of the name, and they have a meaning which we know internally. And then quickly from that, I don't show all the steps, but we generate a tree which represents the logic of this name. And so from that tree in memory, we can generate a structure. And of course, what we generate is a molecule object, which then you can get, and you can generate an image of it or represent it in a different format, like spines or SD or MRV. So that's what's happening. Another feature is that we can correct OCR errors. Sometimes a name like this might have, here it has RN. This one has a O instead of 0 instead of O, or maybe it's a capital O. It's hard to tell. And so we have this option to fix these kind of errors. And so that even though the input name is not exactly correct, it can understand that it's actually this one and then do the conversion as usual. Here it's just another case which is a bit more complicated. Okay, so the API, well, in this case, so the input we have is a string, which is a name, and so here's the example that we used before. And so what we do is that we call here, instead of mole exporter, we call mole importer. And there's basic static method which is import mole. just has one input, which is a string, and it will return a molecule. So given that you are using name to structure, actually here you can see that we didn't even say that we want to import a name. Here's just a string. So the system will actually recognize automatically that it's not SMART, it's not something else, and it actually looks like a name, so it will be imported as a name. So that's what happens in line 2. But in line 3, I just mentioned that you can actually specify that the format is name. And if you know that what you have is a name, then it's recommended because, well, obviously it will not need to detect the format, so that's saving some time. There might be also some cases where either it wouldn't be perfect, or there might even be ambiguities what format something is, in rare cases. So if you know the format, then it's better to specify it. And then once you have the structure M, then you can use it whatever way the ChemAxon API allows you. So either to put it in a database, or to generate an image, or a string representation in another format. So that was for converting one name. Now, I know that what some people need to do is to convert a lot of names, maybe thousands, maybe millions. So obviously you can do this in a loop, and it should be fine, but it might be either not the most convenient, but it might also be inefficient. And it's actually a known issue that currently this method has kind of a startup cost. And so if you use it for a very large number of times, it might actually significantly reduce the performance just because it keeps starting again to load some classes. And this is something we should fix, and we are planning to fix it. But it's good to know. Of course, if performance is especially important for you, then I recommend to use a profiler. I use JVisual VM which is included in the JVM, and which is, I mean, it's a good start. It's very easy to launch even a running program without any specific work, and it can show you. And if you use that, you might see that kind of some class loading or things like that take a time. So if that's important, then I recommend to look for another solution. One way, which is also useful in some ways, is if you have a file full of names, then you, for instance, can release an input stream. And then you can use mod importer, not in a static way like here, but with the constructor, which you pass an input stream, and then you specify. You can specify, again, it's better, but it's a name if you know it. And then once you have the importer, it's actually not quite convenient that you can use a for loop and just iterate for every molecule M returned by the importer. And here you have the body of your loop, and you can do you can process the resulting structure. So it will very simply, you can write this code to process. So if you do this, so obviously it's useful if you have a stream. There are more versions of mod importer that I encourage you to have a look at it if you want to specify the encoding or things like that. Or pass a file directly, not an input stream. And another advantage is that it will not have this startup cost that the static method would have. So if you do for, let's say, hundreds of thousands of names, for instance, it will be relevant that that you can go faster. This is obviously this is not necessarily the most convenient API, so we are going to fix the speed of this version. But if it's not, if this API is not convenient for you and this one is slow for you, then I invite you to contact us, and we can give you some workarounds. I don't want to publicize it because it's kind of a temporary solution. So, but it's certainly possible to solve your specific issue, for instance, with performance. So please don't hesitate to contact me about this. Another remark is that you don't need to specify options to say that now you're converting systematic names or IUPAC names or common names. They're all handled in the same way and recognize automatically. And yeah, again, if it's possible to import anything here, so you have for instance, if you make a web application and you want people to type, or a GUI application, type some structure, you can let them type indifferently a smile or a name or inchi and recognize it using this API. But if you know that you're going to process names, then it's better to specify the format to the API to save some time. Again, names to structure has many options, and I will mention some that are the most commonly useful. So I mentioned the OCR error correction. So there's this OCR option that will activate it, because by default it's off. It might, I don't know if it should be on by default, but kind of historically it was not there. And the thing is that when you use document to structure, we'll see later, it's very often that you will need it, so it's on by default. But if you use name to structure directly, then it's off by default, but you can activate it. And for people who, for instance, want to implement document processing, well, of course, I recommend to use document to structure, but some people have their own process. In this case, it can be interesting to use this option. Then you, for instance, could say that you only want to convert systematic names, so you don't want to use dictionary because maybe you have your own dictionary. So you can use this systematic option. On the other hand, you could also disable the systematic conversion. In this case, it will just do lookup for common names, also certain things like elements, ions. So there are other converters, but it will not try at all to do systematic names. So you can adjust what part of name to structure you want to activate. And then there are things like, for instance, elements. So for instance, I don't know, Cu for copper. These are things that can be converted, but maybe in some cases you don't want to convert that, so you can disable it. Also, there is Cu++ for 2+ for ions. Cas number conversion. It's quite easy to recognize if it's a cas. So basically, it doesn't take any time unless the input is actually a cas. But maybe you don't want to do it because it's using a web service, so you can disable it. That's disabled for document structure by default, but you can activate it if you want. Groups is an option that will stop converting fragments, groups, things like methyl, oxo, so things that are not complete structures. By default, they are converted, so everything you give will be converted, but you can customize that. And there are more options, so I cannot go through all of them, but well, in our online documentation, you have complete list. So all the name to structure options are valid in document to structure, which we will see now. And actually, some of them have different default values, depending on what we thought was useful, but it's probably worth it to have a look at all these options and decide for each of them what is relevant for you and what is the best value. It's also, some of them are probably most relevant when you use from document to structure, but you have the control of that. Okay, now we go to possibility to call a custom web service. That's something that's new in 5.12, which was just released, I think, a couple of weeks ago, because there was a demand for that. And actually, what has been present for a longer time and still available, obviously, is the more generic. There is an API where you can basically register your own class, which will get names and will return structures if it supports this name, or it can be corporate ID, or so. It's a very generic system that uses uses Java classes. And so you could implement this, but this is a simpler way now that you can call your own web service. And you can use it in the GUI or in the applet, but you can also use it using the API. So here, let's look at this code. So we define a URL, which is so the location of the web service, which can take a name as input and which return a structure. And it might be that you are developing this internally in your company for instance, for converting corporate ideas, or do a lookup in your corporate database, or using command dictionary. It might be even a public service. And so so you need to define this. That's the custom part. And if you want to incorporate this in the API, then you can define your web service class. So you call the new web service name converter, and you pass the URL as an argument. And that's generally it's a name converter. It's the API that can modify the behavior name to structure. Next, you need to define a priority because we have many converters, the common names and the systematic names and class and elements. They are running in certain order. And so the idea is that if the priority is high, it will run first. And so if you want, you could use a high priority. In this case, what I did is a very low priority, so in negative and a big number. There is some documentation about the order of the built-in converters. So here the idea is that you would normally use the built-in name to structure, but in case it's something that's not supported, for instance, it might be a corporate idea, then your web service, which is defined here, will be used as a fallback, so after all the others, which can make sense, especially if calling a web service will not be as fast as running locally on the server or on the machine that you are using. So it might be a good idea to do it after the others, but it depends on your use case, so you have the flexibility of this. So once you have defined those variables and those objects, then you can call name converters and add your web service with a given priority. And so from then on, anytime you call the name to structure API or indirectly through the document to structure API, then your web service will be used and will contribute to converting the names. As you see currently, URL is kind of supposing that the name will be at the end. So for instance, we have a query, or it could be end with a slash. It turned out that, in some cases it might not be desirable. So in 6.0, in the next version, it will be possible to actually put a placeholder, this syntax of name, capital, in the URL, and in this case, that part will be replaced by the name instead of being put at the end. If you need that sooner, we can make a more urgent release, or you could actually work around it by defining your own class, because the name converter API is there. So it's going to be more flexible in 6.0. One thing to consider is that when you add your web service or any name converter, it will be used by the whole JVM. In some cases, people wanted to do, for instance, custom conversion for maybe if you think about a your web application. If people have their own preferences, you might not want to affect. Obviously, you don't want to affect, in this case, other threads which are serving other clients, other users. So in this case, there is this variant which is add thread local, which will only apply to the current thread, and it will not affect. So it's only important if you are using many threads and you want to have them several threads, and you want them to behave differently. So obviously the web service is not something you could implement it in any language, in any technology that's just using a HTTP lookup. So you have complete freedom. That's the point of the web service. And as I mentioned, you can use it in Marvin Desktop and applets as well. So maybe the same web service can be used in your API and also in the GUI or only there, so you have the flexibility. It's using the same technology internally, of course. And now we will talk a little bit about document to structure conversion. So what's this? So here you have, for instance, this is a PDF. This is from a patent, and the idea is that you would like to process documents and find structures which are in this document. And so here you see that the output is a list of structures with a set of metadata. It can be here whether it's a common name or systematic name. Can be in the page where it was found in the document, the name of the document, the text. So you can see here it's formulas, here it's a systematic name. The exact metadata depends on the format. So the confidence will be used for image to structure conversion. But some are always there, so the type is always there, the structure obviously in the document. So it uses name to structure internally, but it converts not only names but also smiles, inches, cast numbers optionally, images, an image of a structure, also optionally using OSRA. And it does, in any case, it works also with scanned non-searchable PDF. So in this case, it will do automatically the OCR converting to text. And so you get the structures and their location. And this will work uniformly for all the Microsoft Office documents, also open documents. And in that case, it will find the embedded structures. And it works for PDFs, text documents, XML, HTML, or any text format. There's some special handling for markup in XML and HTML. Okay, so this is what it's doing. And so how can you use it? Well, in this case, what you have is a document. So for instance, probably you can access this document as the input stream. So it's a list of a stream of bytes. And actually, you can see that it's very similar to what we did before with name to structure when you want to do batch conversion. So you have a file or you have input stream as an input, and so you can create a mole importer. In this case, you can say that instead of name, then it's document to structure. So D2S is the abbreviation for that. And again, you could not mention that, and then in that case, you actually have a mole importer which could import anything. So it could be SD file or it could be a PDF, and you actually use exactly the same API. In this case, we specify if we know that we have documents, then we can specify it again. It's a good idea when you know it. And here you can recognize the same way to loop through your hits, through the structures that were found in the document. So for every molecule M returned by the importer, then you have a structure. And so you can do whatever you want with the structure. You could put it in the database, you can manipulate it, you can filter them in any way you want. Here what I'm showing is how to access the properties. So given your structure M, you can access the properties, and then you get the object which is stored in the properties, and there's a list of constants you can find in this ChemAxon.naming.document structure. And from here, the source tags will be what appeared in the document. For instance, if it was aspirin, then it would say aspirin. But you can, and so you get this object, and then you can convert it to string, and you have the text. So you can see in this class, you will see the whole list of properties that can be queried. So it can be the type of the hit, it can be position in characters if it's text format, it can be the page if it's, for instance, PDF. And there is a good number of different properties that you can use, maybe to filter or just to store the information. You don't need to specify the type of document, so it will recognize if it's Office, if it's PDF. And again, you even don't need to specify D2S if you don't need to, if it can be anything. So it can be, if you have imagine a file open feature, you can very easily support documents in the same way as you would support other things without changing your API. Here are some of the options of D2S. Well, you can disable smiles or ONG. If either you know that they won't be there or you actually don't want them. You can control if Ostra will be used or not. By default, it will be used if it's installed. But you might want to disable it because it takes more time, obviously, to recognize the structures. So that's optional. Actually, I can mention that in Linux, it's actually possible if you enable this pitch explicitly, then it will be used because it's embedded with Marvin, but it's not on by default because there's kind of licensing. But it's important that you know that it's not part of Marvin itself. It's something. It's a separate project that you are using. It's also there because it's more difficult to compile it and to install it on Linux. For other platforms, you can very easily install it if you need it. Acronyms, it's an option that will enable the conversion of acronyms such as ATP, which is adenosine triphosphate. The reason it's not on by default is because, well, you can imagine that depending on the kind of those documents that you process, you might have lots of false conversions that are actually not chemicals. So it could be disturbing. And so by default it's off, but you can turn it on if it's useful for you, or you can do your own post-processing. There are options to control which page to process if you have long documents. So either this is for only one page, or you can also specify a range. And there are options for inside tag. If you think about HTML, then probably you only consider with the body of the HTML. So both to save time and maybe even to avoid some false hits, possibly, or in the title. If you don't want to process those, then you can use this option. And there are more options that you can find on the developer website for D2S. And in addition to this, all the options that are in N2S are also available for D2S. So you can also refer to those. So one of the things that I already hinted at is that actually when you are using, for instance, D2S or N2S and S2N as well, you're actually using a standard core ChemAxon class for doing import and export. So obviously internally, when it knows or it recognizes its name or document, it will use specific code, but the API is the same, and I hope it's useful for you because it means you don't need to learn a new one. But it also means that you have many things that's available by standard, which are also available for D2S because it's there more important in general. So for instance, instead of opening input stream, you could want to open a file, or you can deal with encoding of the document. So these things are standard features of more important. Here I want to stress one which might be especially useful if you imagine interactive usage. You might want to know, for instance, display a progress bar, or say processing for instance, a long PDF of maybe 100 pages or more might take time, and so you might want to know where are you in the document. And so there's this API in Mollimporter, which is estimating the number of records, which is estimating how many we think, how many structures will be returned at the end. Obviously, for documents, it's quite hard to guess, but we can make an estimation, and it's useful for progress bar. We can use it for this kind of purpose. So here we just store the estimated total number of hits, and then if you just count one by one each time you get a molecule object, then you can increase your current variable. Then you can multiply this by 100, divide by the total, and you get progress in percentage. It's a double floating number, and then you could display a progress bar in a GUI on a web application. So that part is up to your application. And I invite you to have a look at Model Importer if you want to check all the options that are there. But this is the one that's maybe more specific to, I mean, for processing documents, it will need sort of a specific code because of the specificity of documents. I want to mention, so obviously what do you do when you have a list of structures? Well, it depends on your application. One of the things you might want to do is to index the structures that you found, and so obviously using the JChem base or the JChem cartridge API, you can do this and integrate in your application and your workflow. I want to mention that we've been working on a product called Document to Database, which is one offering for this task. So basically the idea is that building on top of document to structure, we have this product or this tool called Document to Database, which will read documents, to be all the formats that are supported by D2S. Can also access repositories like Documentum or other repositories with further development, and it will process them and find the structures and then create an index in the database. So it can create a database, it can take care of this part of the job. It can handle things like if you process again the same set of documents, it will notice those that are not modified and it will skip them, or it will reindex those that were modified or delete those that disappeared from your source. And so it creates this database that can then be queried, or it can be visualized, for instance, using instant JChem or a web service or a web application or your own application. So this is the architecture. So what do we store in the database? We store structures, which the source, whether it's the name, the smiles, etc., all the metadata I showed before that document to structure returns, and also more metadata linked to the documents. For instance, as I mentioned, we can support Documentum. So in Documentum, there is data that we can use, and all this can be configured. And so once you have this database which is generated by D2DB, then you can ask questions like what structures appear in specific documents, or conversely, you can query what documents contain a certain structure or substructure or similar structure. And if you have metadata, you can do things like what documents written since 2010 in location X, that's your metadata, contains substructure S, or any query you can imagine. So it's customizable in which metadata is extracted from the documents, and given the architecture, the interface is separated from the indexing. So you might use forms in IJC or stock IJC or web app or your own way to access the data. The status is that it's not officially product. It's not, you won't find it on the ChemAxon webpage, but it's because it's been initially developed for custom, a specific customer, and we have made this custom deployment. But it's going well, and so eventually it will be. It's already, if you have a specific project that needs this, then we can work with you and we can make a demo. We can work out how you can use this tool and how you could use it in your company as a developer. You could basically take it off the shelf, so just configure the way you want it to work, and it could be relatively, I mean, it's still going to be some effort because obviously you need a server to index, and it has a lot of moving parts, but it's possible to put it together in a minimal way. Or you could also just use D2DB itself as an indexer, and then because you get a database, it's standard using SQL that you can query it, you can make your own front end for it. So you can have more flexibility if you want to do that. Or you could even want to use the indexer more in a more custom way, or use an API to index documents. That's something that's not the main focus right now. Obviously, it's possible, so we can consider a request to either add features or actually kind of provide an API to this D2DB indexer. I'm arriving to the end of what I wanted to present today. I just want to give links. I think Janos has already put a couple of links in the chat window. So we have extensive documentation in the website. You have this. So and now I'm speaking especially about the developer documentation. So it's a link for name to structure and structure to name. So the naming web page, and then you have a separate page for developers using the document to structure. And then you have the form, which this is a URL directly to the naming section, but you can also just go to the forum and find the naming section of the forum, where you can find previous questions. It's publicly visible, and you can ask your own. Or if you want direct support, or maybe if something is confidential, then you can also use email. Write to naming support. And so just to summarize, so I showed like the simple usage of the API, and I hope it's simple. I think that the basic input-output of strings and structures, or document and structures, is hopefully simple. But it does have many options. So if it seems relevant for you, then please do take the time to look at them and to see which ones would really fit your use case. I did mention that there is some issue with batch performance if you use the API in a certain way, so please consider this and either use the workaround I mentioned, or also contact us if you want to have more information about this. And we're very happy to hear about your feature request, or if you need a new option, or if something is not working as you think it should, then we will happily hear that. And so now I think that you can write your questions in the chat, and Janos will pass them to me, and I will try to answer. So I hope this was useful for you, and waiting for your questions, or right now or by email later. Thank you.